Have you ever thought of algebra not as a math class, but as a new language? I mean, seriously, a powerful language that helps us describe all the patterns and rules in the world around us. Well, that's exactly how we're going to look at it today. So let's start at the beginning, learning the alphabet.
Okay, so back in grade school, we all got really good at arithmetic, right? It's awesome for very specific facts like, 3 plus 5 is 8, no doubt about it. But algebra takes this massive leap. Instead of just one fact, it gives us a rule. See, A plus B equals C isn't just one answer. It's like a blueprint for every addition problem that could ever exist. It's the difference between knowing one street address and having a map of the entire city. It's a total game changer.
And just like any language, you can't just jump in and write a novel. You have to start with the alphabet. We need to get familiar with the basic building blocks before we can start forming sentences.
So first up in our new alphabet is the variable. Honestly, this is the absolute heart of algebra. Just think of a letter like X or Y as a placeholder. It's kind of like an empty box that can hold any number you need it to. Maybe it's the number of people in a room, the temperature, or the cost of something. Its value can vary, hence variable.
And on the flip side, we have constants. These are the solid, reliable numbers we're already comfortable with. Like 3 or -7 or 12. They are what they are. They don't change. They're the fixed points in our algebraic world, the solid ground we build everything else on. Okay, so we have our alphabet now, right? We've got our variables that can change and our constants that stay the same. So, what happens when we start putting them together? This is where we go from just knowing the letters to actually forming words and phrases.
Well, that's what we call an algebraic expression. This is basically the core phrase we use in algebra. It's a string of our variables, constants, and math operations like adding or multiplying, all mixed together. You can think of it like a complete thought, but it's not quite a full sentence yet because you'll notice there's no equal sign.
To really get this, let's just grab one of these expressions and put it under the microscope. We'll use a super common one, 3x plus 5. Now, it looks pretty simple, but it actually has a few distinct parts that are really important to know. First off, let's talk about terms. Terms are just the individual chunks of the expression that are separated by plus or minus signs. So in our example, 3x plus 5, we've got two terms. The 3x part is one term, and the 5 is the other. Simple as that. Now let's zoom in a little closer on that first term, the 3x. You see that number right out front, the 3? It has a fancy name, the coefficient. All it is the number that's being multiplied by the variable. It's basically just telling us how many of that variable we're dealing with. In this case, we have 3 x's. But you gotta be careful. This is where people get tripped up. Sometimes the coefficient is invisible. For real. If you just see a letter x all by itself, there's actually a secret 1 hanging out in front of it. And if you see something like -y, that's really a -1 being multiplied by the y. Spotting these invisible ones is a total pro move, so keep an eye out for them. Okay, so we've got the basic vocabulary down. We know the parts of speech, but how do we actually read one of these expressions and make sense of it all? Well, every language has rules of grammar, and in algebra, our grammar is called the order of operations. You've probably heard of PEMDAS before, right? Maybe you learned, "Please excuse my dear Aunt Sally." Well, this isn't just a friendly suggestion, it is the law of the land in math. It's the universal set of rules that make sure that every single person on the planet reads an expression the exact same way and gets the exact same answer. It's what makes this a truly universal language. So let's put it into practice. When you hear the word evaluate an expression, it just means find its final number value. So for this problem, we're given an expression, and we're told that our variable x is going to be 5. Our job is just to plug that 5 in and follow the rules of PEMDAS. And here's exactly how that works, step by step. First thing, we plug in that 5 everywhere we see an x. Now we just follow PEMDAS. P for parentheses, none here. E for exponents is next, so 5 squared becomes 25. Then M for multiplication. 3 times 25 is 75, and 2 times 5 is 10. And last, we add and subtract from left to right. 75 minus 10 is 65, plus 4 gives us our final answer, 69. All right, your turn. Here's a brand new expression and a new value for the variable. Just use that exact same PEMDAS process we just walked through. Seriously, go ahead and pause right here, grab a piece of paper, and give it a shot. How did you do? The answer is
43! Yes! If you got that, that is awesome. You would have done 4 squared to get 16, then multiplied by 2 to get 32, then you added 3 times 4, which is 12, and finally subtracted 1. You're getting the hang of this.
Now, this is where algebra's true power really shines. I mean, evaluating is one thing, but the real magic is being able to take a messy, real-world situation described in plain English and translate it into the clean, solvable language of algebra. Let's see how it works. So let's take a phrase you might see in a classic word problem: 7 more than 3 times a number. Right now, it's just a bunch of words. Our job is to turn that messy English phrase into a nice, neat algebraic expression. The best way to do it is to just break it down piece by piece. When you see the words a number, that's your cue to use a variable. Let's just use n. 3 times a number? Well, that's pretty straightforward. That's 3n. And 7 more than? That just means we add 7 to whatever we already have. You put it all together and bam, 3n plus 7. Okay, let's try one more. It looks almost the same, but trust me, there is a very important and very sneaky little catch in this one. How would you write 4 less than 5 times a number? Think really carefully about the order of the words. The correct way to write this is 5n minus 4. Now, if you wrote 4 minus 5n, don't worry. You've just fallen for one of the most common traps in all of algebra. Let me show you why that happens. And this is absolutely critical. That little phrase, less than, is special. Unlike more than, it actually reverses the order of things. When we say 4 less than something, it means you have to start with that something, in our case the 5n, and then you take 4 away from it. The way we say it in English is the complete opposite of the way we have to write it in math. It's a tricky one. So, what's the big takeaway here? Learning about variables and terms and expressions, it isn't just about trying to pass a math class. It's about learning a new, incredibly precise language. It's a language that lets us describe the world, model really complex problems, and ultimately find solutions for everything from science and finance to just our everyday lives. So I'll leave you with a question to chew on. Think about your daily routine, or maybe your monthly budget, or a fitness goal you have. What's a pattern in your own life that you could now describe using a variable? Because once you start seeing the world through the language of algebra, you'll start to see these expressions pop up absolutely everywhere.